Hi, I'm Deborah Fowler. This is a continuation of what can we do with the mocap data that we have processed with the Python script. So inside this container, I have information from a set of data files that I've brought in, and I've got a little script here that massages them into Houdini so that we have points in locations. And when we scrub through this, we can see that we have a little action. Right now, though, the data that's coming in is very large. We want to take and transform this down so that we're dealing with something that's a little more reasonable in size, because in dynamics, scale matters. So if I set space G, I now have a character that if I bring in test geometry, that is somewhat correct scale, that this is approximately the right size. So you can see here that I have a actor that was shorter than test Tommy, and this looks about right. Okay, so good. I've got it scaled down. What I'm going to do is create a RBD simulation out of this. So we've got some points. I'm going to go ahead and create an object, in this case a sphere, and I'm going to grab that sphere, and that sphere also needs to be a bit smaller. So let's take this and just shrink this down to something a little smaller, maybe something like that. Okay, so I have a sphere. I've got points. What do I do with them? Well, there's a shelf tool that we can use called RBD Instanced Object. If I click on this, it'll ask me what points do I want to use for instancing. I'll select them and hit enter. It'll ask me what object to instance. I'll select that and hit enter. And now I've got spheres on my geometry. It's also created this DOP network. So this is a DOP network node. It's called auto because it was created by the shelf tool. It's simply a DOP network. So what this does is runs a RBD simulation that when we hit play, it simply falls. Well, we need to add some more interest to this. I'm going to go to the collision tab and add a ground plane. So now when we hit play, it falls. But the problem with this is we have none of the mocap animation that we had. So what we want to do is only have the DOP network take over when we don't want the animation from the animation that we recorded. So what we can do is we can go in here, hit L for tidy, and you can see we have a slightly different structure than my previous files. They've changed this up a bit. It used to be one DOP node, now it's two. This is a null node, just saying I'm bringing this, I'm referencing this in the DOP node. This is bringing the information back from the DOP node. So it's doing the calculation. So you can think of a DOP network as a calculator. So you should never viz the DOP in this case, because it is using proxy geometry referencing in here. We're referencing that information from two DOPs. And if I get rid of some of these extra pieces, in fact, I'm just going to do this. This is the essence of a DOP network. So we have objects, solver, forces. That is the anatomy of every DOP you use, with a few more bells and whistles, too many of them. In fact, we could get rid of this one, which defaults to bullet, and replace that with a bullet solver. And if we run this, you'll see that we have the same results. Okay, so that's our DOP, but we don't really want it to start on frame 1, so let's pick a frame. Let's say start on frame 50. And now we see nothing until we get to frame 50. So what we really need is a switch node. So in here, what we're going to do is we're going to switch between the geometry and the dynamics. So we're going to grab this, and I'm going to flip those two, Shift R, and now we have a switch node. But the problem with this is we haven't added a condition. So we get our animated guy, and then we don't get our DOP, right? If we switch this, we get our DOP, we don't get our animated guy. So what we want to do is say if the frame number is greater than 50, then do the DOP network, otherwise do the animation. Okay, so in here, we switch over, he falls down. Okay. Now, that's all very well and good. What if we wanted to change that frame? Well, it might be convenient for us to have a control on here called switch frame, which I've already set up here. All I did was go into the interface here and drag over an integer value, and that's become my switch frame. So I just called it switch frame. If I hit apply, you'll see that it goes into this area here, and that becomes my value. This becomes my parameter, so, and this becomes my label. Okay, so we have a label and a parameter, which if you float beside, you can see that it's called Kermit. Okay, and let's actually go in and delete this here. Okay, so we have a switch frame, and I'm going to reference that switch frame. So an easy way to do that is to copy that parameter, and we're going to dive inside here, and instead of 50, I'm going to paste relative reference. So I'm going to right-click and say paste relative reference. So now it's referencing that frame. In here, I'm going to do the same thing so we're consistent and paste relative reference. And so now I don't have to worry about what frame I decide to do that switch over. I can just simply do it wherever I decide, and it will adjust. Okay, now there's one other thing that we can do with this, which is interesting. It's to actually have the velocity of these objects taken into account. So let's say we want to do something like, let's move this up a bit and have it motor along, and we can see in here that's going to recache, boom, and then fall down. Okay. So now we've got our DOP happening in here, but we kind of go from traveling along to just kind of falling down. So let's move that in an area where it's a little more obvious. Let's change this to 101. And now we're going to go back and have it fall down. And you can see that abrupt change. What we can do is we can add the velocity that it was going and make that part of the RBD. So let's do that. Let's go in here, actually right before my DOP. I'm going to add a trail node. And in the trail node, I can add a compute velocity, so that now my objects have velocity attribute on them. Cool. Now how do I use that in the DOP? Well, I go into my DOP, and in here I have a tab that says inherent velocity from point velocity. So it's now going to inherit that velocity into the DOP. So now if we play our animation with our simulation, we have roll, and now they continue on their way with the velocity that they left at the end of their, before we switched, at the end of their section. Okay, so that gives us a little more realistic looking animation. Suppose we want to do just the head of the character. In here, we have already set up our points, which we shrunk, and then we've just created a copy to points node, pack an instance, and then I've created an object merge, which is bringing in the sphere into this container. And we're all ready. All we need to do is, instead of doing instanced object, we can just do RBD object. We'll select the object for RBD, hit enter, and it will create my DOP network, much like we did before. Okay, so we have two DOPs. We have this. What we want to do is just have the head spheres, if you will, drop down. So all I need to do is add a delete node. What we're going to do is we're going to grab those points at the top. Well, it happens to be, if I hit wireframe, those are the 5, 0 through 4, the 5 points at the top. I'm just going to turn that off for a point display, just to show you. And 0 through 4, if we do delete selected points and delete everything else, what we get here is just the head points, which is exactly what we want to feed into our DOP network. Okay, so we now have those. We have a rest position, set of attributes, 2 DOPs, and then when we come back out, at whatever frame we're at, in this case, we're doing frame 57, so let's make sure that we're referencing that. Again, we can just copy and paste, copy parameter, paste relative reference, go right up here. And then in here, we're going to add a switch node in a moment. I'm just going to test it first. So we go through and we could see, yeah, it drops. We need our ground plane, and we can drop the head straight onto the ground plane, and in frame 50, there we go. Okay, so we've got our head dropping. Now, if we add back our animated character, switch node, and then grab what we have from our DOP, but we also want to grab what we had before, that kind of works. So if we are less than, so if our frame is less than channel, let's just say greater than channel, switch frame, and it tries to help me. Then do the DOP, otherwise do 0. Okay, so that works pretty well, except for, let's just go to frame 2 here. Boop. Oh, it would help if I visit the switch. Okay, so here we go. And you can see, boom, he falls down. All right, but we want the rest of the body, so we're just going to grab this delete node, and we'll say delete selected. And that way we get the rest of the body. We'll merge that in. And we'll just grab this in here, merge that together. And now we have the entire character. So when the head falls down, we still have the body left. But you can see it kind of falls right through the body. And that's a problem. So what we want to do is create this particular object to be a collision object temporarily as my object. And then I'm going to hit deforming object, grab the object, hit enter. And now what it's done is it's created a collision object for that. Okay, cool. So if I move this over a bit, just to get it out of the way, this is referencing this body leftover as my collision object that is going into the DOP in here. And I've got my collision object, I've got my ground plane, and then I've got my mocap data. Okay, cool. So let's go ahead and run this. Go back to the beginning. You can see that we're kind of missing something, right? We're missing the head. What happened there? So let's go back over here and see, well, in here we viz this because we wanted it to know which object we were selecting, but we are now finished with that, so we're just going to go back to the switch node. Okay, now we're going to run this. And we can see that when we get to the certain frame that we've set up, the head falls off, and it falls without colliding with the body. So it's using that body as a collision object in my DOP, which can be very handy instead of falling through the body. Okay, so that's just a very simple application of the DOP network with a collision object. And we're done.